What's up guys, it's Talha here again, and today we are going to discuss how to use pointers in arrays. So let's get started. So first of all, here I'm going to make a program in which I'm going to elaborate how I use pointers in arrays, and how we access different elements of the arrays through pointers, and how we store address of each element of the array in a pointer, and then we use those pointers, the addresses, instead to display the elements of the array. So first what we are going to do is create an array. So I'm going to create int, for example, int array1, or in just int array, and then when you declare and initialize an array at the same time, so what you do instead, so you don't have to you don't have to write the index number of the array subscript. So you don't have to write the index inside this square brackets. What you can do is just equals, and then you just write your array, all the elements you want to write. For example, here I write 23, 45, and 67, for example. So this is my array of 3 elements, and now this is my array of 3 elements. And now what I'm going to do is I'm going to declare a pointer. So I'm going to say int star p equals and what I'm going to do is I'm going to just write array. So what this statement means is so whenever, this star I'm sorry, the asterisk p is actually the pointer, which is right now storing the address of the first element of the array. So right now this asterisk p, this pointer, is to the type int, is storing the first element's address of this array. So right now it is storing the address of 23 when I write it this way. But if I want to write it implicitly, means if I want to write it if I want to make it exclusive or specific, so for example, if I want this pointer to store the address of this 45 or 67, then I'll have to use the ampersand operator. But right now, if I do it this way, this means that it's going to store the address of the first element of the array. So we're done here, and now what I'm going to do is, so as we know that the type int stores 2 bytes. So if the address is, for example, the address of this 23 right here is 572, the address of this 45 is going to be 574, not 573. So it's going to skip 1 byte, because every integer value in the memory takes up 2 bytes. So that is why when we'll add +1, it will actually jump to the next memory location. Not it won't add 1, it will actually jump to the next memory location. So here I see out so there are 2 ways you can display the individual elements of the array. So the first is, what you do is you do star p. So what this star p is going to display the first element of this array, that is 23, and then we use a string to separate the 2 values. And then what we are going to do is p and 0, like this. So the first way was, what you do is you do asterisk p, which is a general way when you want to dereference the variable, the array in this case. So it's going to dereference, and it's going to display the value of the first element of the array. And then secondly, in this way what you can do is p, so p is the address of the first element, but you know it's also going to show you the address and the value, instead the value of the first element. So you can take it as this 0 is being added to the address of the first element, so that's going to show you the value of the first element. Now see out, so it's going to remain the same. So I'm going to just copy it and paste it right here. So 1 and 2. So I actually have three elements in my array, so I'm going to use three statements. So int star p plus 1. So as I stated earlier that you know, if you add 1 to this address, it's going to jump towards the next location. It's not literally going to add 1 to the location, but it's going to jump towards the next location of you know, subsequently following the first location. So p1 and p0, and as I stated here, this is another way, so you can take it as this 1 is being added to the first address. So it's basically the same thing as this one. And when I do this p plus 2, so here when I add 2, this does not mean that it's going to add 2. That means it's going to move towards the location after. So that means it's going to move the location after the second location. It's going to skip one location. It's going to skip one location and it's going to move towards the second one. It's going to skip one and then it's going to go to the location following the previous one. So here, and I'm going to here write 2. So this means that the 2 is being added here. So when I run the program, let's run the program and let's see if it works. As you can see, it's working perfectly fine. And so you know, here we use three statements. So what we can do instead is do it inside a loop. So what we are going to do is let's create a for loop. So let's make a for loop where we declare I int I equals 0, I is less than or equal to 2, because I have three elements in my array, so 0 1 2. So it's going to have so the 0th element is 23, the first element is 45, and the second element is 67. And then I increment I by 1, and then when what I show here is cout p and I, and then so what's going to happen here, this loop is going to execute. So first the value of I is 0, the p, so the p also, p is actually the p, there's a pointer which is actually storing the address of the first element of the array, so p is storing 23. And as I stated earlier, that you can take this statement as if the value inside this square bracket is being added to the address of the first location. So when 0 is going to add to p, it's going to just give you the value of the first location, and you know, so for following this method is going to give you the address, the value of the second and the third location. So let's see if it works. I'm actually going to insert cout endl so the code can be a little neat. So, oh sorry, something wrong. As you can see, it's working perfectly. Now there's another way you can do it. So here, so right now you are not moving the pointer, you're not scrolling the pointer, so pointer is at the same place, but instead what you're doing is you're incrementing I. There's another way you can do it is by initializing a for loop, and what you do is for p for int for int star p1 equals array. So it's a pointer which is initialized. So it's going to have the first, it's going to have the address of the first location, first value in the array. Then I say that p1 is less than or equal to. So now right now what I'm going to is I'm going to be a little specific, because I don't want it to go second above the second location of the array, that is 0 1 2. So array, I'll say array 2, no, and array, and then I don't want it to go above 2, so like this. And then I increment p, I increment p1 plus plus, and then what I do is I see out star. So star is when you dereference, so it's going to instead show you the value of the variable. So in this case that's an array. So endl, and let's see if this works. We just copy this and paste it here. Let's see if this works. As you can see, this is working perfectly fine. This is because, so here let me give you guys an idea what this for loop is about. So in this for loop, int asterisk p1 is another pointer which is storing the address of the first element of the array. So it's storing so right now it's storing the address of 23. Next, the condition is when p1, which is the pointer, is less than, this pointer variable has the value less than or equal to, and now right now I'm being specific. So ampersand array2. So it's the while the address of while p1 has an address which is less than or equal to and array2, so less than the address of 67, because I don't want to go beyond 67, because that will give me a garbage value if I do that. So if it's less than the and ampersand array2, so it's going to execute this, and then star p1. So star p1 is going to dereference and give you the value of the variable of the location instead, and then it's going to increment p1 by 1, so that means it's going to move towards the next location. Now p1 is on the next location, which means on 1. So p1 has the address, so right now p1 is going to have the address of 45, which is less than which is less than the address of array2, the element of the second location, that is 67. So this statement is going to execute again, and it's going to stop when this address is going to be, so when p1 is going to be is going to have the address of 2 is going to have the address. So when p1 plus plus is going to be 3, so then this loop is going to terminate, and this loop is going to stop. So right now, as you can see, all of the 3 methods work. So it's up to you which method you want to choose, but personally I like the second one better, because it's pretty simple, and the first one is, a little lengthy, and the third one is a little complicated, but it's up to you which method you like. So I hope you like this video, and I'll see you guys tomorrow.